you're going to see that we get some.
You're gonna see that we get some help here on the
Some help here on the static semantics.
static semantics, and I'm gonna do an example in
Okay, so I'm going to do an example in a second.
second, meaning that the system, some languages are
Meaning that the system, some languages are better than others.
better than others on it, but it will try and help you catch
On it, but it will try and help you catch some things that
some things that are not semantically correct,
are not semantically correct statically.
statistically.
In the case of Python,
In the case of Python, it does that, I think, all at runtime.
it does it, I think, all at runtime. I'm looking at you again, John.
I'm looking to you again, John. I think there's no
I think there's no pre-time check.
pre-time checks. Professor John Gutteag, unintelligible.
Sorry?
Professor Eric Grimson, there is some.
There is some, okay.
Okay.
Most of them are,
Most of them, I think, though, are primarily caught at run
I think they were primarily caught at runtime, and that's
time, and that's a little bit of a pain because you don't
a little bit of a pain.
see it until you go and run the code. And there are some.
Because you don't see it until you go and run the code. There are some actually going to see it.
Actually, we're gonna see an example, I think, in a second,
An example, I think, in a second where you find it.
where you find it. But you do get some help there.
But you do get some help there. The problem is
things that you catch here are actually
things that you catch here are actually
the least worrisome bugs.
these worrisome bugs. They're easy to spot.
They're easy to spot. You can't run the program with
You can't run the program with them there, so you're not.
them there. So you are not gonna get weird answers.
Going to get weird answers.
Not everything is gonna get caught in
Everything is going to get caught in static semantics.
static semantics checking.
It's checking. Some things are going to.
Some things are gonna slide through, and
Slide through, and
that's actually a bother,
a bother.
because it says your program will still give you a value.
Because it says your program will still give you a value, but it may not be.
But it may not be what you intended, and you can't always
What you intended, and you can't always tell, and that may.
tell, and that may propagate its way down through a whole
propagate its way down through a whole bunch of other
bunch of other computations before it causes some
computation, before it causes some
catastrophic failure.
failure.
So actually the problem with static semantics is you'd like
problem with static semantics is you'd like it to catch everything.
To catch everything, you don't always get it.
You don't always get it. Sadly, we don't get much help here. Get much help here.
Which is where we'd like it.
Which is where we'd like it, but that's part of it.
But that's part of your job.
Your job.
What happens if you actually have something that's both?
Okay. What happens if you actually have something that's both
syntactically correct and appears to have correct static?
Correct and appears to have correct static semantics in you.
Semantics, and you run it.
Run it.
It could run and give you the right answer. It could crash.
Could run and give you the right answer.
It could loop forever. It could run and apparently give.
Could crash. Could loop forever. It could run and apparently give you the right answer.
Give you the right answer.
And you're not always going to be.
And you're not always gonna be able to tell.
Able to tell. Well, you'll know when it.
Well, you'll know when it crashes. That doesn't help you.
Crashes doesn't help you
very much, but you can't always tell whether.
But you can't always tell whether
something's stuck in an infinite loop, or whether it's
stuck in an infinite loop, or whether it's
simply taking a long time to compute.
Simply taking a long time to compute.
You'd love to have a system that spots that for you, but
have a system that spots that for you, but it's not possible.
It's not possible.
And so to deal
with this last one, you need to develop style. All right?
Right?
Meaning we're gonna try to help you with how to develop.
We're going to try and help you with how to develop
good programming style, but you need to write in a way
programming style, but you need to write in a way in which it is going to be
gonna be easy for you to spot the places that cause those semantic bugs to occur.
Places that cause those semantic bugs to occur. All right.
If that sounds like a really long preamble, it is.
It sounds like a really long preamble. It is.
Let's start with Python. But again, my goal here is to let you see what computations about why we need to do it. I'm gonna remind you
why we need to do it. I'm going to remind you one last time.
Our goal is to be able to have a set of primitives that we combine into complex expressions. Which we can then abstract to treat. We can then abstract to treat as primitives, and we
abstract to treat as primitives. And we want to use that sequence of instructions in this flow of instructions in this flow of control.
Control computing in order to deduce new information.
Computing in order to deduce new information. That imperative knowledge.
That imperative knowledge that we talked about right there.
Knowledge we talked about right there.
So I'm gonna start today. We have about 5 or 10
I'm going to start today. We have about 5 or 10
minutes left. I think in order, 5 minutes.
Left, I think, 5 minutes left in order to do this.
Left in order to do this with some beginnings of Python, and we are gonna to pick this up obviously next
really pick this up obviously next
time. So simple parts of Python.
So simple parts of Python. In order to create any kinds of expressions, we are gonna need values.
Need values.
Primitive data elements.
Primitive data elements. And in Python we have two to start with. We have numbers.
2 to start with.
And in Python we have two to start with. We have numbers.
And we have strings.
And we have strings.
Numbers is what you'd expect.
Numbers is what you'd expect.
There's a number.
There's a number.
There's another number.
There's another number. All right. Strings are captured in Python with an open quote and some.
Are captured in Python with an open quote and some
sequence of characters followed by closed quote.
Characters followed by a closed quote. Associated with
every data type in Python is a type.
Every data type in Python is a type,
which identifies the kind of thing it is.
Some of these are obvious.
Some of these are obvious. Strings are just a type on their own. But for numbers, for example, we can have a variety of types. So this is something that we would call an integer or an int. And this is something we would call a
floating point.
Floating point or a float. Or if you want to think of it as a real number.
But as a real number. And there's some others.
And there's some others that we can see.
We're going to build up this.
We're going to build up this taxonomy, if you like, but
this taxonomy, if you like, but the reason it's relevant.
The reason it's relevant is associated with each one of.
It is associated with each one of those types.
Those types is a set of operators that expect certain.
Is a set of operators that expect certain types of input.
In order to do their job.
In order to do their job. And given those types of
And given those types of input, we'll get back output.
input, we'll give back output. All right.
All right. In order to deal with this, let me show you an example.
In order to deal with this, let me show you an example. I hope that comes
And I hope that comes up. Great.
up. Great. What I have here is
What I have here is a Python shell. And I'm gonna just
a Python shell. I'm going to just show you some simple examples.
show you some simple examples of how we start building
Examples of how we start building expressions.
expressions.
And this will lead
And this'll lead into what you're gonna see next time,
into what you're going to see next time, as well as what you're going to do
as well as what you're gonna do tomorrow.
So, starting with this shell,
starting with the shell, I can type in expressions.
I can type in expressions. Actually, let me back up.
Actually, let me back up and do this in video.
I can type in a number.
I can type in a number. I get back a number. I can type in a
I get out the number. You can type in a string. You get
string. I get back the string.
back the string. Strings, by the way,
Strings, by the way, can have spaces in them. They can have
spaces in them. They can have other characters. It's simply
other characters. It's simply a sequence of things, and
a sequence of things. And notice, by the way,
that the string 5,
that the string 5, the string digit
strings digit 5 digit 2 is different
5-digit 2 is different than the number
than the number 52.
The quotes are around them.
The quotes are around them to make that distinction. We're gonna see why in a second.
See why in a second.
What I'm doing, by the way, here is I'm simply typing in
What I'm doing, by the way, here is I'm simply typing in
expressions to that interpreter.
To that interpreter.
It's using its set of rules to deduce the value and print
set of rules to deduce the value and print them back out.
Back out.
Things I might like
to do in here is I might like to do
in here is I might like to do combinations of things.
Combinations of things with these. So we have associated with simple things a set of
associated with
operations.
Set of operations.
So for numbers we have the things you'd expect.
So for numbers we have the things you'd expect, the arithmetics.
Arithmetic.
Let me show you some examples of that. Now,
what I typed in things like, well, let me start this way.
Actually, I'm going to do one other distinction here. What I've typed in, things like, well, let me start this way.
And in Python, the expression is operand, operator.
There's an expression. And in Python, the expression is operand, operator, operand.
operand when we are doing simple expressions like this.
And when we're doing simple expressions like this, and if I give it to the
And if I give it to the interpreter, it gives me back
interpreter, gives me back exactly what you'd expect.
exactly what you'd expect, which is that value.
Which is that value.
Okay?
The distinction I'm going to make.
The distinction I'm gonna make is that an expression.
Because that's an expression. The interpreter is going to get a.
The interpreter is gonna get a value for it.
Value for it.
When we start building up code, we are
start building up code. We're going to use
gonna use commands
or
statements, which are actually things that take in a value and ask the computer to do something with it. So I can similarly do this, which is gonna look strange.
So I can similarly do this, which is going to look strange because it's going to give me
because it's gonna give me the same value back out, but
same value back out, but
it actually did a slightly different thing.
It did a slightly different thing,
and notice, by the way, when I typed it, how print showed up.
By the way, when I typed it, how print showed up in a different color.
In a different color.
That's
the Python saying that is a command, that is a
Python saying that is a command, that is a specific command to get the value.
Specific command to get the value of the expression and
the expression and print it back.
Print it back out. When we start writing code, you're gonna see that.
When we start writing code, you're gonna see that difference. So for now,
difference, but for now, I don't worry about it. I just wanna
don't worry about it. I just want to plant that idea.
Plant this idea.
Yeah. Okay.
Once we got that, we can certainly
Not that we can certainly though
do things like this.
Things like this. Notice the quotes.
Notice the quotes around it. And it treats it as a string. It's simply getting me back.
String is simply getting me back the value of that string.
The value of that string. 52 times 7 rather than
string 52 times 7 rather than the value of it.
The value of it.
Now, once we've got
that, we can start doing things.
Now we can start doing things, and I'm going to use print.
And I'm gonna use print here. If I could type in
here, if I could type in
order to just to get into that, I can't type. Here we
get into that. I can't type. Here we go. In order to get
into the habit.
Into the habit. You can print out a string.
I can print out a string.
I can print out Here's a first example.
Here's a first example of something that caught. This is a static semantic error.
One of my things. This is a static semantic error. So what went on here?
So what went on here?
I gave it an expression that had an operator.
I gave it an expression that had an operand in there. It expected arithmetic types.
Arithmetic types. But I gave it.
But I gave two strings.
Two strings. And so it's complaining.
And so it's complaining at me, saying you can't do this.
Yeah, saying you can't do this. I don't know how to take.
I don't know how to take two strings and
strings, multiply them together.
Multiply them together.
Unfortunately, John, you may just.
Unfortunately, now, John, you may disagree with me on this.
Agree with me on this one. Unfortunately,
in Python you can, however,
do things like
this.
Like this. What do you figure that's going to do?
What do you figure that's gonna do?
Look legal.
Look legal.
String.
The string 3 times the number 3.
3 times the number 3. Well, it happens to.
Well, it happens to give me 3 threes in a row.
Give me 3 threes in a row. I hate this.
I hate this. I'm sorry, John. I hate this.
Because this is over.
Because this is overloading that multiplication operator.
Loading that multiplication operator
with two different tasks. It's saying if you give me two numbers, I'll
do the right thing.
Do the right thing. If you give me a number and a string, I'm gonna
concatenate them.
Concatenate them together. It's really different.
There's really different
operations, but nonetheless, it's what it's gonna do.
But nonetheless, it's what it's going to do.
Student, unintelligible.
There you go.
Professor Grimson. There you go.
There will be
there will be a rebuttal phase a little later.
Rebuttal phase a little later on, just like
with the political debates, and
political debates, he likes it as a feature.
Likes it as a feature. I don't like it. You can tell he's not.
I don't like it. You can tell he's not
a Lisp programmer, and I am.
Programmer, and I am. All right, I want to do some.
All right, I want to do just a couple more quick examples.
A couple of more quick examples. Here's another one.
Here's another one. Give you an example of a syntax error.
Example of a syntax error.
Because 52A doesn't make sense.
Doesn't make sense. And you might say, wait a minute.
And you might say, wait a minute. Isn't that a string?
Not a string, and the answer is no.
And the answer's no. I didn't say it's a string by putting
I didn't say it's a string by putting quotes around it.
Quotes around it.
Notice how the...
And notice how the machine responds differently to it.
The machine responds differently to it. In this case, it says...
In this case, it says, this is a syntax error. And it's...
This is a syntax error. And it's actually highlighting...
Actually, highlighting where it came from, so I can go...
Where it came from, so I could go back and fix it.
Back and fix it.
All right.
All right.
Let's do a couple of others.
Let's do a couple of other simple examples.
Simple examples. Right? I can do multiple.
All right. I can do multiplication.
Multiplication. I've already seen that.
I've already seen that.
I can do addition.
I can do addition.
3 plus 5.
3 plus 5. I can take something to a power, double star, just take...
Something to a power, double star. Just take 3 to the 5th power.
3 to the 5th power.
I can do
division, right?
Division, right? Whoa.
Whoa.
Right?
Right?
3 divided by 5.
3 divided by 5 is 0.
5 is 0? Maybe in Bush I can... I'm not going to...
Maybe it Bush econom. Maybe it Bush econom. No, I'm not gonna do any political
comments today. I will not say that.
Comments today. I will not say that. All right.
All right. Right. What happened?
What happened?
Well, this is one of the...
Well, this is one of the places where...
Places where you have to be careful.
You have to be careful.
It's doing...
It's doing integer division.
Integer division. So 0,
integer division. So 3 divided by 5 is 0 with a...
Divided by 5 is 0 with a remainder of...
A remainder of 3.
3. So this is the correct answer.
So this is the correct answer. If I wanted to get full real division, I should make one of...
Get full real division, I should make one of them afloat.
Them afloat.
And yes, you can look at that and say...
And yes, you can look at that and say, well, is that right?
Well, is that right? Well, up to some level.
Well, up to some level of accuracy. Yeah, that's 6 is...
Level of accuracy, yeah, that's 0.6 or
Point 6. What I'd like to get out. All right?
Right. I can
do other things.
Other things.
In particular, I have similar operations on strings.
I have similar operations on strings. Okay, I can certainly print.
Okay, I can certainly print out strings, but I can actually
add strings together.
Add strings together, and just as you saw, I can multiply.
And just as you saw, I can multiply strings. You can
strings. You can kind of guess what this is gonna do.
Guess what this is going to do?
It is gonna merge them together into one thing.
Merge them together into one thing.
I know I'm running you slightly over. I wanna do.
And you slightly over. I want to do one last example, which I also want to.
One last example. It's I also wanna be able to do. Have
variables to store.
Variables to store things.
Store things.
And to do that in this, it says if I have a value,
to do that, this says if I have a value, I want to keep it around.
Want to keep it around. To do that, I can
to do that, I can do things
like this.
Like this. What does that statement do?
What does that statement do?
It says create.
It says create a name for a variable, which I just did.
Name for a variable, which I just did there. In fact, let me type.
There, in fact, let me type it in my string with an equal.
Type it in. My string with an equal sign, which is
saying assign or bind to that name the value.
Assign or bind to that name the value of the following
expression.
It's a consequence.
As a consequence, I can now refer to that just by its name.
Just by its name. If I get the value.
If I get the value of my string, there it is, or if I
my string, there it is, or if I say
take my string and add to it the string my last name, and
string and add to it the string my last name, print it back out.
Print it back out.
This is the first.
So this is the first start of this.
Start of this. What have we done?
What have we done?
We've got values.
We've got values, numbers and strings.
Numbers and strings. We have an operation.
We have operations to associate with them.
Associate with them. I just threw a couple up.
I just threw a couple up here.
Sure, you're going to get a chance.
You're gonna get a chance to explore them, and you'll
see not
only are there the standard numerics for strings.
The standard numerics for strings, there are things like length.
There are things like length or plus or other things you
Length or plus or other things you
can do with them.
And once I have
values, I wanna get a hold of them so I can
because I want to get a hold of them so I can give them names.
Give them names.
And that's what I just did.
And that's what I just did when I bound that.
When I bound it,
I said use the name my string to be bound to, or have the
name my string to be bound to, or have the
value of Eric, so I can refer to it anywhere else that I
of Eric, so I can refer to it anywhere else that I
want to use it. And I apologize for taking you over. We'll come back to this.
We're taking you over. We'll come back to this next time.
Next time, please go to the website to sign up for.
Go to the website, sign up for recitation for
tomorrow.